Hey Lisa, how are you? Long time no see.
Hi Zain. Yes, I am fine. How about you?
Yes, I'm fine too. Why are you look so dull and complicated?
I've got several things I can't cope up with computer organization architecture subject.
Oh, okay. So, what does the assignment about?
It is about memory management and I could not be able to understand it.
It's okay, no problem. Chill up. I can help you to complete this assignment.
Oh, thank you so much friend for your help.
Nah, unmentioned. Hey Lisa, I found a video that related to your subtopic. Check this out.
Really? Let's watch it together.
Yeah, for sure.
What is main memory? Main memory refers to a physical memory that is the internal memory to the computer. The main memory in a computer is called random access memory. It is also known as RAM. Computer that store operating system software, software application and other information for the central processing unit CPU to have fast. It is called random access because the CPU can go directly to any direction of main memory and does not have to go to about the process in a sequential order. RAM is one of the faster type of memory. It is also has the capacity to allow data to be read and written when the computer is shut down or the content held in RAM is purged. Main memory is available in two types. Number 1, dynamic random access memory, and number 2, static random access memory. The CPU is often considered the most important element in the performance of a personal computer. RAM probably comes in a close second. Having an adequate amount of RAM has a direct effect on the speed of the computer. A system that lacks enough main memory to run its application must rely the operating system to create additional memory resources from the hard drive by swapping data in and out. When the CPU must retrieve the data from the disk instead of RAM, it slows down the performance of the computer, such as many game, video editing, or graphic programs require a significant amount of memory to function at an optimal level. Process of RAM. The central processing unit is one of the most important components in the computer. It is where the various tasks are performed and output is generated. When the microprocessor completes the execution of a set of instructions and is ready to carry out the next task, it retrieves the information it needs from RAM. Typically, the direction includes the address where the information which needs to be read is located. The CPU transmits the address to the RAM's controller, which goes through the process of locating the address and reading the data. RAM is dynamic random access memory. Is the most common kind of main memory in a computer. It is a prevalent memory source in PC as well as workstation. Dynamic random access memory is constantly restoring whatever information is being held in memory. It refreshes the data by sending millions of pulses per second to the memory storage cell. RAM is known as static random access memory. Is the second type of main memory in a computer. It is commonly used as a source of memory in embedded device since RAM is less dense and more power efficient when it is not in use. Therefore, it's a better choice than RAM for certain use like memory caches located in CPU.
Hello guys, my name is Shaanjiv son of Ravi Kumar. My mentry ID is BTAL 20060449 from Software Development course. Want to present about memory management. Memory management is the functionality of an operating system which handle and manage primary memory and move processes back and forward between main memory and disk during execution. Memory management keeps track of each and every memory location regardless of either it is to be allocated to some process or it is free, and it checks how much memory is to be allocated to process. It decides which process will get memory at what time. It tracks whenever some memory gets freed or unallocated, and correspondingly it updates the status. In memory management, there's got two kinds of system, and it is uniprogramming system and multi-programming system. In an uniprogramming system, main memory is divided to two parts. One part for the operating system and other part for the program currently being executed. In multi-programming system, the user part of memory is subdivided to accommodate multiple processes. The task of subdivision is carried out dynamically by the operating system and is known as memory management. In uniprogramming system, only one program is in execution. After completion of one program, another program may start. In general, most of the program involve input-output operation. It must take input from some input device and place the result in some output device. And yes, this is the figure about partition of main memory. To utilize the idle time of CPU, we are shifting the paradigm from uniprogram environment to multi-program environment. Since the size of main memory is fixed, it is possible to accommodate only few processes in the main memory. If all are waiting for input-output operation, then again CPU remains idle. To utilize the idle time of CPU, some of the process must be offloaded from the memory and new process must be brought to this memory place, and this is known as swapping.
A very good day, everyone. My name is Jesintha Devi, daughter of Letchumanan, and my metric ID is BTAL 200603772, and I'm from Course Software Development. Today, I would like to share some information about swapping from the main title of Memory Management. What is swapping and how does the process of the swapping placed on? Swapping is a memory management scheme in which any processes can be temporarily swapped out from main memory to the secondary memory so that the main memory can be made available for other processes. It is used to improve the main memory utilizations, and in secondary memory, the place where the swapped out process is called as a swap space. What is the purpose of this swapping? The purpose of the swapping in operating system is to access the data present in the hard disk and bring it to the RAM so that the applications program to use it. The thing is to remember that swapping is used only when data is not present in the RAM. Although the process of swapping affects the performance of the systems, it helps to run and more than one processes. This is the reason why swapping is also refers to a memory compaction. A process needs to be in a memory of executions, but sometimes there is not enough main memory to hold all the currently active processes in a time-sharing system. So, exist processes are kept on disk and brought it to run dynamically. Swapping is the process of bringing in each process in a main memory, running it for a while and then putting it back to the disk. So, what does the advantages and the disadvantages of using swapping? Advantages of swapping is, firstly, it helps the CPUs to manage multiple processes within a single main memory. Second, it helps to create and use virtual memory. Third, swapping allows the CPU to perform multiple tasks simultaneously. Therefore, processes do not have to wait for very long before they are executed. 4. It improves the main memory utilization. What are the disadvantages of having the swapping? The disadvantages are, first, if the computer system loses the power, the user may lose all the information that related to the program in case of substantial swapping activities. Second and last, if the swapping algorithm is not good, the composite method can increase the number of page faults and decrease the overall processing performance. That's all about swapping from me. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Hilmy bin Mohammad Seripudin. My metric number is 060550 and I am Bachelor of Computer Science Software Development in UNISA. I would like to share with you all about partitioning in memory management. Partitioning is splitting of memory into sections to allocate processes including operating system. There are two types of partitioning. The first one is fixed size partition and the second one is variable partitions, or known well as dynamic partitions. Fixed partition is categorized as contiguous, which means each process is contained in a single section of memory that shares a common border and is next to or together in a sequence. There are two kinds of fixed partition, which are equal size partition and unequal size partitions. The most important point to remember is that each partition can only contain single process. For equal size partitions, the memory is partitioned to fixed size partitions. For example, in the input queue, we have some processes which are waiting to be loaded into the memory. The process 1 that require 2 megabytes of memory is loaded or be placed into 8 megabyte partition. In this partition, only 2 megabyte is used. The remaining 6 megabyte cannot be used by any other process, so it is wastage. Next, the process 2 that require 4 megabytes of memory is loaded or be placed into 8 megabyte partition. In this partition, only 4 megabyte is used. The remaining 4 megabyte cannot be used by any other process, so it is wastage. Then, the process 3 that require 2 megabytes of memory is loaded or be placed into 8 megabyte partition, and the process 4 that require 3 megabytes of memory is loaded or be placed into 8 megabyte partition. At last, the process 5 needs to be waiting. We cannot allocate the remaining memory to the waiting processes. In every partition, we may have some unused memory. Internal fragmentation is the wasted space within each partition. For unequal size partition, the size of each block in fixed partition is varied, where processes are assigned to the blocks where it fits. In other words, processes may be queued to use the best available partition. The differences between equal size partition and unequal size partition is the memory rate used. In the unequal size partition compared to equal size partition, memory wastage is minimized. Memory wastage is minimized but still not give best throughput, as some partitions may be unused. The unequal size partition use two types of queues. Processes assigned to memory block. There are multiple queue and single queue. In multiple queues, each process is assigned to the smallest partition in which it fits and minimize the internal fragmentation problem. In single queue, the process is assigned to the smallest available partition and the level of multi-programming is increased. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Izzat Irfan bin Shaharum. My metric number is 060552. Today, I will continue for the next scheme for partitioning. Let's go. Okay, the scheme is variable or dynamic partitioning in operating system. This is a second scheme after the fixed partitioning in operating system. Okay, for the dynamic partitioning, it is tries to overcome the problems caused by fixed partitioning. In this technique, the partition size is not declared initially. It is declared at the time of process loading. The first partition is reserved for the operating system. The remaining space is divided into parts. The size of each partition will be equal to the size of the process. And the partition size varies according to the need of the process so that the internal fragmentation can be avoided. Okay, for the next slide is about advantage of dynamic partitioning over fixed partitioning. Number one is no internal fragmentation. Given that the fact that the partition in dynamic partitioning are created according to the need of the process, it is clear that there will not be any internal fragmentation because there will not be any unused remaining space in the partition. Number two is no limitation on the size of the process. In fixed partitioning, the process with the size greater than the size of the largest partition could not be executed due to the lack of sufficient contiguous memory. Here, in dynamic partitioning, the process size can be restricted since the partition size is decided according to the process size. And number three, the last advantage is degree of multi-programming is dynamic. Due to the absence of the internal fragmentation, there will not be any unused space in the partition. Hence, more processes can be loaded in the memory at the same time. Okay, let's see the next slide is about disadvantage of dynamic partitioning. The disadvantage is external fragmentation. Okay, absence of internal fragmentation does not mean that there will not be external fragmentation. Let's consider at the three process on this picture. At process 1, 1 megabyte, and process 2, 3 megabyte, and process 3, 1 megabyte are being loaded in the respective partition of the main memory. After some time, process 1 and process 3 got complete and their assigned space is freed. Now, there are two unused partitions, 1 megabyte and 1 megabyte, available in the main memory, but they cannot be used to load a 2 megabyte process in the memory since they are not contiguously located. The rule says that the process must be contiguously present in the main memory to get executed. We need to change this rule to avoid external fragmentation. Okay, for the last slide, I will share for you all about complex memory allocation. In fixed partitioning, the list of partitions is made once and will never change. But in dynamic partitioning, the allocation and deallocation is very complex since the partition size will be varied every time when it is assigned to a new process. Operating system has to keep track of all the partitions. Due to the fact that the allocation and deallocation are done very frequently in dynamic memory allocation, and the partition size will be changed at each time, it is going to be very difficult for operating system to manage everything.